Hey everybody, this is Larry. This is May 27th, the 27th day of the May Leetcode Daily Challenge. There's only about a couple of days to go, so if you're with me so far, congrats to yourself. But let's finish it before we congratulate ourselves too much. So yeah, hit the like button, hit the subscribe button, join me on Discord. And my allergies are kicking. I'm still suffering a bit from allergies. I've been taking all the medications that I can over the counter. But my point is that if I'm sniffling too much or sneezing too much, my apologies. Hope you're doing all right. But today's problem is maximum product of word lengths. So I'm going to solve these live. So if it's a little bit slow, it's a little bit awkward. Well, it is live, so you're seeing someone doing it for real. But just watch it on 2x, fast forward, whatever you need to do. Okay, so given a strain array words and return a maximum length words i's and j where two words do not share common letters. If no such two words exist, return 0. Okay, so this is pretty I mean in theory it is straightforward. It is that there's probably this optimization that's needed. So if you choose, because they're n words, right? So n is 1,000, and if you just choose every possible pair, that's going to be n square, or n choose 2 if you want to be precise, which is still a lot. And because each word length could be up to 1,000 characters, if you do a naive comparison of two words, that's going to be too slow. So one thing that we can do is note that we can process, we can do something about try to figure out how do they share common letters. Well, they share common letters if they contain the same words or same letters, right? That's what it means. Obviously. So then you can pre-process, and if they're all lowercase, that means that we can pre-process that into a 26-letter character. Oh, sorry, 26-letter alphabet, right? So you just basically check, in a naive way, you can do if A is in B and A is in, if the letter A is in the first word and the second word, then it's no good, right? That's basically what you would do. And I'm gonna take this opportunity to do a little bit of bit mask. I don't think it's necessary, but Python being the way it is, I think in other languages I might not bother, but in Python I might a little bit. Because on Leetcode and some other judges, Python is a little bit slow, and 26 million, like a million times 26 would be not even, like you wouldn't even have given a dot in say Java, but in Python, at least on Leetcode, it's a little bit sketch. So anyway, so the thing that I would like to say is that, okay, bitmask is really just a fancy way of saying it is an array of bits, or an array of booleans, if you will. Basically, you have, okay, so let's say you have a 26, so let's just say you have an array of 26 elements, right? So for example, you have an array of 26 bulls, one for each alphabet. So then in that way, it could be, the first index will be if A is true. Like if it contains A, then it'll be true. If it doesn't contain B, then it's false. Does it contain C? True, sure, whatever, right? Let's just say this is the word ABC, right? And then dot dot dot, just a lot of force afterwards because there's nothing afterwards, right? So the idea behind a bit mask is just converting this true false array of booleans into binary bits instead. So for every true we have 1. For every false we have 0. So in this case, it'll be 1, 0, 1, and then maybe 23 zeros for the rest of the alphabet, right? And that's basically the idea. And then the thing with this is that it so happens that it lends itself to a very easy set intersection, because let's say you have two words, let's say ABC as above, and then maybe another word that's Larry, right? Whatever. So then now, does it have an A? Yes. Does it have a B? No. Does it have a C? No. And then dot dot dot. Where L is, and then it's true. Dot dot dot. True on R and Y, right? And then for something like that, right? But the idea here is that okay, now this also has a Boolean array, or with your bit mask. If you translate or this thing, it looks something like this. I'm too, I'm not. This is not accurate because I'm not counting it to the thing, but something like that, right? So let's just say you have two things, right? And then now let's reduce it a little bit. Let's actually, let's reduce this. But using the bitwise operator, and well, what happens, right? And you can do a truth table or whatever, but this is basically the truth table. I'm writing it out for you, but and you can tell that the set intersection means that for every bit we look at it one bit at a time from these two masks, and the result would have a 1 if both of these contains the same character in the same place, right? So then now you go backwards, right? If this Boolean array and this Boolean array have no intersection where they're both true, then it would have all false in the bitwise AND. And all false in the bitwise AND is, of course, equals to just the number 0. So that's basically the idea. I'm doing a little bit hand wavy on the bitmask stuff. I just want to get you started on how bitmask works, like a little bit idea. Play around with it. The cool thing about bitmask is that each bit, for the bitwise operations, each bit act on each bit independently. So that means that as long as you're not doing something funky, this bit will the fifth bit will never interfere with the third bit and so forth, which is what you want in this case. So yeah, okay. So with all that set up, it's still, I know that I didn't explain it fully with what bitmask is, but hopefully this idea that this idea of just I know it's intimidating sometimes and it looks like a lot of math and funky operators and bit shifts and stuff like that, but in essence this is all that is. This is saying, okay, we just have an array of Boolean values, or set with an array of Boolean values, and we just do some operation on it. And in other languages, you can actually just use those Boolean arrays if you want to play around with that. But like I said, in Python and some other instances, it's nice to kind of have this optimization. So yeah, so let's get started. So now first we can pre-process each word. So let's just have a mask is equal to, let's say n is the number of words. Mask is equal to 0 times n. So a number whatever. Maybe I didn't need to do it that way. Maybe I could have done something like this and then just mask out append, calculate mask for word, say, right? And then you calculate mask for a word. You have your current mask is equal to 0, turn mask at the end, and then for character in word, we know that is lowercase, right? Yeah, okay, only lowercase. So you take the ordinal value, you minus it from the ordinal value of a, and that's your offset from the ordinal value, and then you just mask is you set that is equal to 1 shift by offset. And this again looks a little bit mathy and tricky, but what this is saying is, if you have questions about these codes, just write, or not write them out, but draw them out, right? What this does is that it takes the number 1 and then it adds essentially adds offset number of 0, right? So if offset is 0, this is the answer. If offset is 1, you have 1, 0. It becomes 10, which is 2 in binary, or the other way around maybe. 10 in decimal, 2 in binary, or I said it wrong again. 2 in decimal, 10 in binary, sorry. And, you know, if offset is 5, for example, you have something like this, right? Where, you know, so that's basically the idea here. And then the OR is just taking the current mask, and the OR, as you know from the truth tables, just sets it to 1 if it's not already 1. And yeah, if it's already 1, then it doesn't matter, right? It doesn't change anything. So that's basically the idea about these masks. And basically, but in English, what I'm saying is just, you know, set the offset character to true, right? In the lookup table, you can imagine this to be saying another way of doing it is a way of offset is equal to true, or you know, maybe or true if you want to mirror that a little bit. But that's basically the two things are equivalent. Cool. Get a lot of questions about bit mask. That's why I'm going over it a little bit today. Hopefully, you know, we'll see how that goes. But yeah. And then now we have one for each word, and I forgot what the question is. Just the number of pairs. Maximum value of, oh yeah, maximum value, okay. So then now we can go through it in a pairwise kind of way. So let's just have a best value. I just said mx, short for max. And then I think in this is more Pythonic to use iter tools, but I always forget how to do iter tools combinations. Maybe. I can't remember if that's combination is in iter tools or is one of their recipes. But let's try it then. For xy in iter tools that combinations of word of mask. Yeah, because now we only care about the bit masks. Well, actually, the way that I write it is very awkward in general, to be honest. But let's just do it with two for loops. I think I'm getting too fancy. So let's just do for I is in range of n, for j is in range of I plus 1 n, just so that you don't, you know, is n choose 2. And then now mask of I. So we do this bitwise, which is a set intersection, essentially. If this bit intersection is equal to 0, meaning that they have no intersecting sets, intersecting bits, then now we take the max is equal to the max of the max, and then the length of words sub I times length of words sub j. And you can actually pre-cache this. I think it'll be a little bit faster. I'm not don't hold me to it, but yeah, but that's pretty much it. I mean, I know that this is a little bit longer video because I went over bit mask and stuff, but this is just essentially a brute force way of doing it. And given that n is 1,000, this should be fast enough, because the bitwise operation means that you save a for loop, and you know, because another way of thinking about it is that it could have, you know, instead of writing this, you could do a for loop through A to Z, and that would give, you know, the same answer, but it'll be 26 times slower, just the way that computers are generated or whatever. Anyway, let's give us submit, and that's good. So yeah, so what's the complexity here? Again, this is going to be n choose 2. In terms of space, we have linear space because we calculate a bit mask for each word. Yeah, that's all I have. I think if you really wanted to, you can maybe do, you know, if you want to look at the equivalent one, I could do something like this where, you know, just so that you can have so that you can kind of have a reference of how they translate. And this is, you know, essentially how they translate, right? or maybe in this case I'll just have force times 26 instead to be even more equivalent. As, and then you would have something like, you know, and then now the equivalent, and this code is a little bit weird, but yeah, if set sub I, I think maybe something like that. I actually know that in Python you could use this thing in the intersection, so that is actually really code for set intersection. But I just wanted to be maybe more explicit about it. But yeah. So basically, you can do that, and this is equivalent, right? And you could kind of do the translation essentially. Ooh. Oh, I forgot that these are actually lists. So okay, my bad. But if you want to, yeah, okay, I was a little bit wrong there because usually I make this into a set, but I changed my mind. But yeah, but in this case, you can do something like, you know, just how you know, something like that. I'm just doing a little bit awkward. So yeah, if, right. Of course, this is gonna be 26 times slower, but you know, yeah. I mean, though I guess technically I didn't prove that it was correct. Here, there you go. But yeah, but again, it'll be slower. But yeah. Anyway, I hope this serves as a good intro to bitmask as well. Can't fit this in a page anymore, but you get the idea. But yeah, that's all I have for this problem. Hit the like button, hit the subscribe button, join me in Discord. I'll see you out tomorrow. Have a great rest of the week. At least in the US, it's a long weekend, so you know, enjoy yourself. At least here in New York, the weather's been pretty. And until today, it was pretty good. So we'll see. Anyway, see you later. Good mental health. Take care of yourself, and I'll see you later. Bye bye.